Hi, welcome back to another mechanics question. Here we have a table and a pulley and two particles that are connected together. Okay, let's have a look at this. So the question is two particles A, B, masses M and 2M, respectively attached to the ends of a light inextensible string. Particle A lies on a rough horizontal table. String passes over a smooth pulley P on the edge of the table. B hangs freely below the pulley as shown in the diagram. Coefficient of friction between table and A is mu. Particles released from rest with the string taut immediately after release. The magnitude of the acceleration of A and B is 4/9 g. Okay, so a lot going on there. Find the tension of the string immediately after the particles begin to move. Show that mu is equal to 2/3. Okay, so let's have a look at this. So here I'm just going to get rid of all the question. Okay, go back to it if you want to have a look at it. But I'm going to do away with that because I need some working space. So we need to find the tension, okay? So let's have a look. First of all, we've got particle A. I'm going to put in the weight for A is going to be mg, and the normal reaction is going to be the same, right? Because it's not accelerating vertically. So it's going to be R equals mg, that's why I like that. And with B, we're going to have weight is 2 mg. And then we've got the light inextensible string, so we'll have tension there. And of course that tension will be exactly the same here as well. Tension. When it's moving, B is going to move vertically downwards. I'm just going to check the acceleration on that again. What does it say? 4/9 g is the acceleration. So let's just put it in now. So 4/9 g is the acceleration. And of course for A, it's going to accelerate this way. Because when that moves, because of the connection of the string, this could move. So it's going to be like this motion here. Okay, and so 4/9 in that direction. And then lastly, because it's a rough table, because mu was mentioned, I've got to put in a friction there. So I'll go write F for friction. That's it. That's the force diagram done. Get in the habit of drawing these up pretty quickly because it's essential to setting up our equations and solving the whole question. So what we're going to find the tension of the string immediately after the particles begin to move. So what I'm going to do is I'm going to look at particle B first of all, just because there's fewer forces going on. Okay, if I looked at particle A, I'd have to consider tension and frictional force, but with B, I just need to look at that and that. Okay, so for B, let's write it here, shall we? For B, we've got acceleration is downwards, so 2 mg will be positive, and then subtract t, because it's in the other direction, is equal to mass times acceleration. So the mass is 2m, and the acceleration is 4/9 g. Okay, and in this question, because we're not told what m is, we're probably not going to have to worry about that. Let's have a look, see what we can do with this. So I can put the t onto that side and put this onto that side. So that's going to be 8/9 mg. Okay, so it's 8/9 mg plus t is equal to 2 mg, and then if I just do 2 mg subtract 8/9 mg, I'll get my value of t, won't I? So t is equal to 2 subtract 8/9, so that's going to be 1 and 1/9, 10/9. 10/9 mg. Says find the tension and doesn't say how to leave the answer, so I think we can leave it with that. But as I said, we're not going to work out what m is because we haven't been given enough information for that, so we have to leave our answer in terms of m. If you want, you can write down what that is when you use g as 9.8, 10/9 times 9.8, but I don't have my calculator on me today. Well, not for this question. So I'm just going to leave it like that. Okay. Show that mu is equal to 2/3. Right, well, because we've done the motion for B, we're going to have to consider the motion for A, aren't we? So let's do that now. So A is moving towards the right, so tension is positive, and then subtract from that the friction. I'm going to write mu r. Remember, we can use the equation F equals mu r when we've got friction involved. So I'm just going to write T subtract mu from r is equal to mass times acceleration. Here the mass is m, and the acceleration is 4/9 g. Okay. I've got t already, so I can substitute that in. So 10/9 mg. Subtract mu times r, which is mg. So subtract mu times mg is equal to, here I'll simplify that as 4/9 mg. Now here's the nice thing about questions like this, the m's will cancel in this equation. Notice that? You can just divide that by m here, 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 and we're just left with a much simpler equation. Let's just write that down. So 10/9g, remember that's just a number because g is 9.8. Subtract mu g, again 9.8 times by mu is equal to 4/9 g. You know what, I can cancel out the g's as well, can't I? I can just cancel out the g's. Okay, so why don't I do that as well? G, 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 OG. Sorry, another poor pun there. There's plenty of those if you've been watching my videos. I just can't help myself with these things that just come up. So what we're going to have, so put the mu onto that side, 10/9 subtract 4/9, so that's going to be 6/9. So mu equals 6/9, which will simplify to 2/3. And where are we at? Yes, isn't that nice? Isn't that nice? And I show that question when you get the answer you expected. Okay, so I'm just going to put a therefore, because it's to show that question. Basically saying, look, hey, I've done it. That's what the therefore means mathematically. Therefore mu equals 2/3. Okay. I'm going to pause now while I set up the next part of the question. Okay, back again. So here, this is what I set up. So next, when B has fallen a distance h, it hits the ground, does not rebound. So B hits ground, that's it, falls h in distance. A is then a distance h/3 from P. So basically, A is moving, of course, when B hits the ground. There's a distance of h/3 from P. Find the speed of A as it reaches P. Okay, so what's happening is this is going to stop without rebounding, but then A is going to keep on moving, isn't it? Okay, there's been some questions on this previously, but when B hits the ground, A doesn't just suddenly stop with it. It will suddenly decelerate and come to a rest. So there's a couple of things going on. First of all, let's have a look at B then. So for B, whoops, let's get the pen. For B, we need to find out the speed at which it hits the ground. All right? So it starts from rest. So just check that for you. The particles are released from rest. So U is equal to 0. And the acceleration, A, is 4/9 g. And the distance, I want to write h, I use s, of course, for distance. The distance that it falls is h, okay, and we've got to find what v is. So we're going to use v squared equals u squared plus 2as for that one. Okay. So u is equal to 0, so we've got 2 times a times s. All right, I'm running out of space here, so just put some working up here. So v squared is equal to 2 times a, so that's going to be 8/9g times by s, which is h. Looking nice, isn't it? So that's that. Okay, that's what v squared is. Now notice I've not gone and taken the square root of that, because you'll see there's no need. What that tells us, okay, is that when b hits the ground, it is moving with the speed of v squared equals that. A is moving at the same speed. We need to consider what's happening after that motion. Okay? So after that motion, after B hits the ground, we have got A is moving with speed U squared is equal to that. Now where this is going is we're going to have to use V squared because U squared was 2as again. Okay, that's why we don't actually need to work out what U or V actually is, because we can nicely write it like that. Now, so A is going to be moving with initial speed U squared equals this. We need to see what the speed is as it reaches P, so we've got to find what V actually is. we know that the distance it travels, that's handy, isn't it, is going to have to be h over 3. That's why that's 1/3 h. The acceleration, we're going to have to work that out. Okay, we're going to have to work out what the acceleration is. To do that, we're going to have to go back to the equations of motion again. I'm going to have to get rid of this, I'm afraid. That's the thing about mechanics questions. I normally need a lot of space for this, and when I'm doing a video, it's a bit difficult, so I have to rub things off. Okay? So what's happening is, when B hits the ground, the string becomes slack. What that means is essentially there's no tension in the string anymore. Okay, it will become slack, and just A will then come to a rest gradually because it's on a rough table. But according to this, it won't come to rest straight away. It actually hits P before it does so. So for particle A, I'll set up the equation again. Sorry, that's not written very neatly, is it? So it's going to accelerate in that direction. Okay, there'll be a deceleration, which means the acceleration will be negative, but it's moving in that direction still. Okay? So without the t, we'll just have negative f there, aren't we? Okay, so negative f is equal to mass times acceleration, and we need to work out what that is. We worked out what the frictional force is already. Okay, the frictional force. Where's the frictional force? Mu r, where r is equal to mg, and mu is equal to 2/3. Let's just write that down. So the frictional force was mu r, so 2/3 is mu r, negative 2/3 times by mg is equal to ma. Okay, and that, I'll just show you that again so you can see. So we had f is equal to mu r, where we worked out that mu, or we're told that mu was equal to 2/3, so 2/3 of r, where again r was equal to mg. The m's will cancel in that, and we just got a is equal to negative 2/3 g. Right. So a is negative 2/3 g. Now we can work out v is, again using v squared equals u squared plus 2as. So u squared was 8/9 g h plus 2as. So subtract 4/3 g times s, which is 1/3 h. Oh, I'm running out of room again. Oh, curse this question. Well, I'm just running out of room. So what I'm going to do this time is I'm just going to get rid of that and move this upwards a little bit. There we go. Yes, I can create a bit more space and do it that way. Because I don't really want to just write down an answer, I want to show a bit more working. So 8/9 GH, subtract, that will be 4/9 GH. So 8/9 subtract 4/9 is 4/9 GH, and that's what V squared is. So V is equal to the square root of that. So 2/3 times root GH. Yeah, 2/3 root GH. Yeah. I think that will be fine as an answer. If you want, work out what root 9.8 actually is, times it by 2/3, and then that times h, round to two significant figures. Lastly, state how you use the information that the string is light. When we use the fact the string is light, let's just go back to it, okay? We're seeing that the tensions are the same. Okay, tensions are the same. And of course, when we assume that tensions are the same, we can set up an equation for B involving negative T and for A using positive T. Okay, so that's what you need to write down for that. State how you use light, tensions are the same. Hope you found that useful. Thank you for watching.